welcome.
Hello, hello.
Welcome
It's us
to
again.
It's us again. Are you here voluntarily? What are you doing? Welcome to Choose Your Own Adventure, or you choose a Choose Your Own Adventure style show through the CNCF landscape. So glad to have you here, friends. This is going to be an exciting episode. I'm especially excited. Do you know why?
I'm pretty sure it's related to my comment earlier on Twitter, right?
Yes.
Yeah, I have no idea what's going on today. I
Yes.
honestly have no idea. Zero.
I love it.
Nix. Nada. Ništa. I can
So-
say in any language you want how much I know about this subject.
So, if you have questions, you better ask them now, because Victor will be asking so many questions. And we do the first come, first serve thing. But we didn't even say, we should say what this episode's about. It's about workload identity.
Yes.
Yeah.
It's about identifying culprits.
It's about, so when we say workload identity, we specifically mean not people, machines, robots.
I mean,
Processes.
let's face, who wants people around? Come on. That's why we are all remote online, so that we, God forgive if we meet in the same location.
We'll talk about people getting access to things next week, or being identified. It's not really about access. It's just about establishing who they are. And then what you do once you have that identity, that's a whole other ball game. That's another episode entirely. But before we dig in too much about workload identity, let's chat about last week's episode. We talked about artifact signing last week.
Yes. Signing and confirming that the one who signed it, or he or she got fired and cannot sign anymore.
Again, robots and machines can sign too. But yes, so I guess revocation is it's like the consequences for signing that something is true when it's not true. You can't be trusted anymore. So increasing trust in your system by signing artifacts, which is an interesting thing about signing, is you're signing an attestation, and the attestation is saying something's true. But it's not like you could attest that the sky is pink and grass is orange and sign it, and then that's signed. So there's no...
but then that's the point. It's written. You can sign that the earth is flat, but then I have your signature on it. That's the point.
Yeah, that's the point. But you are increasing trust in your system. You're establishing integrity and authenticity. So it is what you think it is, and that it wasn't modified in transit is the idea.
Not necessarily only that it is what you think it is, but also that it passed through the phases it was supposed to pass, right? So you can say, I'm signing this because I'm confirming that this thing was tested, right? Mm-hmm. Even though there is no physical evidence in that something that it was really tested, right?
Yeah. So that's a great point, because when I think of signing, I think a lot about signing container images. But you're talking about signing maybe like an attestation that goes along an artifact while it goes through a supply chain, and maybe the signature has to do with like a vulnerability report, or that it passed a certain suite of tests, or that sort of thing.
And you can still sign that same image. You can say, okay, this person signed this image to confirm that it's tested, and this person signed to confirm that it is what it is, and the third person signed it because to confirm that there are no vulnerabilities in it. Now, that last one is never signed because that never happened. But, hey.
Or that last person's a liar.
Exactly.
And then I mean, this is a rhetorical question, but I wonder how often a person signs it. In my mind, it would be like a build system would sign that, or it goes, like, when's a human really interacting with this?
But a person initiates that build.
Yes.
Right?
Okay.
Or a person initiates merge, or a person signed the code review, right? So very often there is a person behind it, right? Not necessarily person who directly initiated the process that signed it, but there is a person still behind it, right? Most of the time, because ultimately, until we get to the stage that we are not writing code anymore, right?
Yeah.
Then yes.
So there's automation that in place. So then let's talk about the tools. First, let's talk about the outlying tool, which was open policy containers.
Yes.
This is last week's episode. Open policy containers wasn't really a signing tool. It does do signing, but the whole idea behind it is it takes OPA policies and then it wraps them, it makes them into OCI V2 containers, and then you can store and distribute and tag and all the things.
And sign
it. Makes it easy. And sign it. And sign it. So we let them, they're a technology that doesn't really fit anywhere, and we let them choose what episode they wanted to be a part of, and they chose the signing episode. So they were there. And then we had 2 actual signing technologies on last week. We had SigStore and Notary. Tell us about SigStore.
You can sign and you can validate that it's been signed. Now ask me about Notary.
What's Notary, Victor?
You can sign something, and you can validate that it's been signed.
Excellent. Crystal clear.
There you go. I like to make it clear. That's my mission. Yes.
So SigStore uses short-lived certificates, the X509 certificates. They're only valid for 10 minutes. And SigStore has sub-projects. It has Full CO, which is a signing authority. It has Recore, which is a transparent public, immutable public log. And it has Cosign, which is the CLI tool to sign things and verify things. So it has a 10-minute certificate, and then it persists the signing event to the public log. And then part of the verification process is verifying using the public log as part of your verification. So the idea is you don't have to manage their certificates and keys. That's the plus side. The drawback is that if you're in an air-gapped environment, or if you're super compliance heavy, or like there is a public record of your signing event out in the world, and some people don't want that, and those people probably choose Notary, which does have longer lived PKI certificates that you have to then store and manage, but then it's probably more compliant if you're concerned about that sort of thing.
You're now shaming my explanation, right? Is that what's going on here?
One thing I don't understand still is about revocation. Like a Notary has a revocation strategy, but with SigStore, if there's like an identity that you're like, I don't trust this person said there are 0 vulnerabilities, therefore I trust nothing, and that they said, then in SigStore, I don't know how that works with the public log, because the public log is immutable, so you can't retract do you amend it again? I don't know. That's what I don't know.
I mean, I'm guessing that I'm not sure how many use cases that are there to retract, right? Mm-hmm. That was signed by whomever or whatever signed it, right? Mm-hmm. Now, if you want to make a new image with the people you trust, go ahead, right?
Just do it again. Yeah. So maybe sure. I accept that. Revocation just doesn't matter sometimes. That's a good.
The fact that you fired somebody does not mean that somebody didn't sign anything.
Yeah. But it means you have to re-sign everything they signed. Yeah.
Go ahead.
All right, so that's a recap. And so now we need to know, what did the people choose?
The people chose,
da, da, da,
and
da.
I see that the system does not hide what I voted.
No. Notary
project.
project. Awesome.
Yeah.
And so Notary has gotten a revamp. Notary used to be it's like a legacy client server, and it's not that anymore. And Victor, I think before we do the demo, we probably should come clean about or something. You and me.
About something? What was that something?
Yeah.
That you mean that no choice was illusion. Is that what you were trying to say? Kind of like, it was all a scam. We make people vote, and then we make sure that they vote for the only thing that can be voted. And most of the time we succeed. Is that what you're trying to say?
We got lucky these last 2 times. Although, or maybe like, okay, so in the choose
Subliminal
your own...
messages, Whitney, don't underestimate it.
In the choose your own
I even
adventure.
put a public vote myself for Sixtor to make sure that people vote opposite.
There you go. Yeah, yeah. And so in the choose your own adventure book, sometimes you hit a dead end. So we hit some dead ends in our story, which we've done before. We did it during chapter 1. And so during the scanning episode, we included Cubescape and Sneak, excuse me.
Sneak.
And Sneak is not a CNCF project. So had you voted Sneak, we would have, I don't know, I would have fainted. We would have slapped you on the hand. We would have said, sorry.
No, we would.
No can
We
do.
would find out the names of everybody who voted and shame them publicly. We would put it on a screen over there.
It would just like scroll during at the bottom of our
Exactly.
screen during the whole next episode. No, we would never
That's
do
it.
that. Like, we need more voters as it is.
We would.
And then last week, Sigstore is not a CNCF project, so that if that one, it can't be implemented. And also, Open Policy Containers is a CNCF project, but since y'all didn't choose OPA back weeks ago when we did the admission controller, then we wouldn't have been able to implement Open Policy Containers. Therefore, even if you didn't vote Notary, we would be implementing Notary today. But
That's how
playing
good of
along.
people we are. Doesn't really matter what you do. We already made up our minds. That's the point of what Whitney's
Well-
trying to tell you in a very, very nice way.
there are plenty of times where it's a real competition, but I think the Cubescape episode would have been a lot less interesting if we didn't have a second technology to compare it to, similar to Notary. It's a better conversation. It's entertainment value.
Yeah.
Okay, what do you say we implement Notary into our
Notary,
ongoing
you say,
demo?
huh? Okay, can you bring my
Notary
screen on?
projects.
There we go. This one is going
Yes.
to be easy, really, because of... I already gave you the explanation. I'm not going to show anything beyond the explanation I gave. Right? And that explanation, you can sign it, you can verify. There we go. Docker image. I'm going to build an image. Right? There we go. I'm going to use TTL simply because it's... you know what TTL is, Whitney?
TTL,
It's a
what is,
temporary... It's a container image registry that keeps your images only for a day. So it's great for trying
cool.
out and stuff like that. It's just gone afterwards, right? Anyways, I'm building
Smart.
image. It's building. And it will continue building for a few more seconds.
My container registry, and Docker Hub has stuff from 5 years ago.
So I'm going to push image to the registry. I just built it, pushed it. This is nothing to do directly with signing, but it needs to be done. And it will be pushed there in a minute. And I'm going to get image digest, right? Digest of the image, because that's the reliable way to identify something, right? And that image digest is this one, right? That's the full address of the image. Reliable one. Now comes to Notary, right? I can say notation ls list of what you have for this image, and you can see that you don't have much except that that there is image itself. That's not important. What is important is that I'm going to sign that image. I'm going to give my stamp of approval that this has been tested. And it has no security vulnerabilities and none of those things, right? So I signed it, I confirmed, I put my job on the line, notation, and I can now verify it, right? I can verify, is this image really signed by somebody? And it failed. And I have no explanation, I did something wrong. But imagine that it didn't fail. Imagine that this requires a lot of creativity in your part, that it worked, and you would see that I signed that image.
Excellent.
There we go. That's all
There
there
we
is to
go.
it. You can sign it, and you can validate it when it works.
Excellent. Awesome. Ba-ba-da-da. Notary project. So now we get to workload identity. Here we are.
Now we get to the things I have no idea about.
So normally during this part of the episode, we talk about what is workload identity, and we're going to evaluate 3 tools today, and we might talk about what you should be looking for when you evaluate these tools. But now we're just going to have a conversation that consists of a lot of questions. Well,
Okay.
first of all, a statement. The technologies we're having on today are SPIFFE, which is a specification. So it won't be a part of the vote. It's a specification. Then we have SPIRE, which is the reference implementation of SPIFFE. And then we have a guest on representing Athenz that also generates workload. And also, I know it at least supports SPIFFE's SVIDs. Oh, we're saying words that you might not know yet, and that's okay.
Fancy.
Yeah. But let's talk about, so these are all methods for auto-generating work identities for workloads. So yes.
Mm-hmm. Go ahead.
How are workloads generally identified?
By SPIFFE, SPIRE, and Athenz.
No, before these technologies existed, workloads still had identity. Like, this isn't a new
still
problem.
had to identify them, right? But in the past it was, and this is my really uneducated, more guess than anything.
Yeah.
In the past it was much easier because you knew much more than we know today, right? So for example, in the past I knew that, okay, you know that server that never goes down, that's where this thing is running. It's over there, right? I knew where things are, I knew what things are, and so on and so forth. Now everything is so dynamic, right? You cannot really, it doesn't matter whether we're talking about machine identification or human identification or something. I don't know anymore where things are running, and wherever they're running, I don't know where they will run 2 minutes from now, right?
Yeah.
Everything is highly dynamic. Everything goes up and down, moves around, and gets deployed and redeployed, and so on and so forth. So it's much more challenging to establish what something is. And without knowing what something is, many of the other things later on become more complicated. Like, hey, you want to authorize something to be able to do something. You cannot really do that without knowing what that something is in the first place.
Right. So I have lots to say, but the ways that I'd heard of before SPIFFE, SPIRE, Athenz were MTLS. That I think about encryption as part of that, but also part of that is a service being able to say what it is. And then the other thing is tokens are a way, identity tokens, right?
Ask me what Cilium uses for MTLS.
What does Cilium use for
SPIRE.
MTLS? I knew that because you demoed it a few episodes ago.
There we go,
Yeah.
right? So you still need, you cannot establish MTLS without knowing what something is. You need to identify things, whatever those things are, right? No matter what you're going to do, and this goes beyond today's subject, but I don't know, like, you cannot forward traffic to something without knowing what that something is, among other things, and so on and so forth, right? So you need to identify things one way or another.
Right.
That's for sure, right?
So X509 certificates, a private key is one way to do that. Yeah. And then the other way that I've heard of that I know about in my greenness is identity tokens. Yeah. But so I think then the question becomes, why are these not good enough? Why did the world need to make SPIFFE, SPIRE, Athenz?
I have a strong suspicion that somebody else is going to answer that one.
Oh, well, I have... Yeah, but I want it to be a conversation.
Go. Converse, woman.
Well, I understand. So again, like, tokens are kind of before my time, or I haven't dealt with tokens directly. But my understanding is those need to be stored, and just like certificates need to be stored and rotated and shared. And Cert Manager does a good job of it for certificates. I don't know what's going on with tokens, to be honest. But I understand that those could get hard coded, or they're easier for hackers to get, or that sort of thing. But I'm not speaking with confidence, but that's what I've been told about shortcomings. Another thing is, if you have a system that uses tokens, or how do you get two completely different systems to talk to each other? So if I had it all to do over again, I would do people authentication first. I wish I did. I wish we put in the schedule next week's episode today and this week's episode next week, because I think there's a good analogy to be made for, you know how OIDCs made it logging into a website a consistent experience no matter what website you go to across the internet. And even though it might be implemented differently under the hood, as a user, you only see this interface. That's what I understand SPIFFE SPIRE, like this identity layer is to machines needing to access each other. They have this layer on top that makes it so no matter where two machines are interacting with each other, whether it's across different systems, or even if it's like something maybe needs to connect to a database or whatever, it can use this identity layer sitting on top to have a consistent experience no matter where it's accessing another thing or establishing identity.
I'm in a listen mode in this episode, so
okay. Is this good TV for us to guess what everything is while we have like real experts sitting backstage to tell us? So let's do this. Let's have our experts on. Let's see how we're doing. We're gonna introduce Frederick first. Frederick, come on. Tell us about yourself, please. Thanks for being here.
That's the hardest question. So I'm Frederick. Some of you may have seen me in the past. I did a lot of work with KubeCon, used to co-chair it. My connection here is I've done a lot of work with SPIFFE. I'm on the SPIFFE steering committee. I also have done a lot of work in Kubernetes and Docker and networking and variety of different areas. So it's an area I'm passionate about and hoping I can help shed some light on what's going on here.
Excellent. Wonderful. Was there any glaring mistakes in anything that we've said so far that need to be corrected ASAP?
I don't think so.
Okay.
I think in terms of things like mutual TLS, like I think the conversation went really well. Like he gave a really good description of it, and nothing I would change.
Oh well, thank you very much.
he's just being polite.
Politeness doesn't help anyone learn anything. I want to be told when I'm wrong, please. But we'll see you when you present here very shortly. Thank you, Frederick. And next on, we have Daniel representing SPIRE. Welcome, Daniel.
Thank you so much for inviting me on this show, Whitney and Victor. It's really good to be here. So just to introduce myself, I've been working in the workload identity space for a long time. Back in 2017, I worked at a backup software company, the biggest backup software company. They had backup agents at thousands of different organizations, running on thousands of different servers at each organization. And they really wanted workload identity, end-to-end workload identity, to encrypt all the data coming off of all of those agents. So I led that project to implement workload identity throughout that organization, millions of agents at tens of thousands of different sites.
Cool.
Fascinating project. That was a great start to work in this space. So then I joined a startup called Cytail, which developed the original version of the SPIFFE and SPIRE standards. We got acquired by HPE. At HPE, I did a ton of consulting. If you look at all the companies using SPIFFE and SPIRE, I've worked with most of them at some point.
Wow.
I can't say all their names because I think that would be trademark infringement or something, but I've worked with almost all of them at some point in the last couple of years. And now I'm doing some new work around SPIFFE and SPIRE that I am not going to talk about today, but I can in the future. You can find my conference talks on YouTube pretty easily and see the kinds of things I'm working on, though. So that's a quick introduction.
Yeah, thank you so much for being here and sharing your time and expertise with us. We'll see you very shortly.
All right, I'll be back.
All right, last but certainly not least, we have Abjeet here to teach us about Athenz. Hi, Abjeet. Tell us about yourself, please.
Hi, my name is Abhijit. I'm a senior principal developer here at Yahoo, and I am a maintainer of Athenz. So I'm
Awesome.
happy to be here.
So happy to have you. We'll see you shortly. All right, Frederick, we're bringing you up. This is the real thing. I'm going to put your thing on the stage, and as soon as you start talking, Victor will start the time.
Fantastic. So let's get started. So first, we're going to cover SPIFFE. So SPIFFE itself is a specification. So a lot of people think of SPIFFE as like an implementation. They often think of like SPIRE or Istio, but SPIFFE itself is similar to the same way you have an HTTP spec that describes what HTTP is. Then you have multiple implementations of HTTP. SPIFFE itself is also a spec, and there are multiple implementations of SPIFFE, and we love them all. And so there is also a SPIFFE book out there. So I want to toss this out first because if you like the information that's here, or you just want to get more information how authentication works, even if you have no intention on actually using SPIFFE, there's information in here that gives a basis as to why SPIFFE exists and could be useful in other contexts as well. Especially there's a section on how PKI works that a lot of people have said independently of SPIFFE it's been quite useful for them. So let's get into like why SPIFFE first. Like why does it exist? And it's trying to be an answer to this, where you have a trusted network. You're trying to establish communication between them securely, and this is like perimeter defense. And the entire industry is trying to move away from this because there's significant security issues with it, where an attacker gets into a trusted network, then they can communicate over that VPN or start attacking workloads. And what we're trying to move is to this, where we have secure connections between workloads. Not between the networks alone, but where the primary defense is the attested workloads. So if an attacker gets in, then they have to do additional work in order to attack those workloads. So again, same thing. We have a set of connections. If the attacker gets in, then they will start to do horizontal or lateral movement throughout the system. And the idea is to try to establish this in such a way where some of the icons did not pop up. StreamYard messed it up. There were little fire icons that were between all of the nodes. But basically, we're trying to set it up so all communication occurs within these little trusted channels rather than this one primary channel. So to get to here, there's a number of things that need to happen. You need to have identity, which is what we're talking about here. You need to have policy that does something with that identity, and you have to have a way to control it all. How do you automate it? How do you scale it? How do you make sure it's doing what you want it to do? And what we're trying to build is this. We have at the very top, we have a root CA, a root certificate. And these intermediates can get created that say, like, this is my e-commerce site. This is my HR site. The e-commerce site may say, I have a web server and I have a payment server, I have a database, et cetera, et cetera. And each of these microservices need to get attested. So we're moving into a world where there's much more dynamic workloads to get spun up and spun down. So before, this was all done manually. Now a lot of this work is being done through automated means. There's several ways to do this. You're going to hear about two of them very shortly. So ultimately, this is the goal: is how do we issue and run these and reason about them across multiple locations? And then once we have established identity, then this is looking into the future. You can then write policy where your policy is no longer based on IP addresses. Your policy is now based upon this trust domain, and this front end needs to connect to that system, and you specify exactly what's allowed and what actions are allowed. So the way this works within authentication with SPIFFE is every SPIFFE has an SFID, or rather a SPIFFE identity. I'll update the slides on this later. SPIFFE identity, it consists of a schema that says, hey, this is the SPIFFE identity, a trust domain, this is example.com or mycompany.com, workload identifier, which is the name of the application that is trying to connect or you're trying to identify. This ends up inside of a verifiable identity document, which is based on X509, which is the subject alternative name is the exact place where it ends up living as a URL, or it ends up in a JWT token in a way that has been signed. Please ignore the redundancy on this. But in short, you want to have something that has been signed by something that you explicitly trust that has the ability to sign that. It's something that's your identity provider. SPIFFE also provides a workload API, and you don't have to implement every single thing on here. Like the SVID is different from the workload API. The workload API is a part of the spec that says, how do I actually issue? How do I deliver this identity to something? It delivers the SPIFFE ID, delivers the X509 SVID, and the list of CAs that it should trust. So if you would like more information, I have QR codes up here. You can go back on video and scan them with your app. Thank you.
Thank you. That was beautiful. That was a great presentation and perfect timing too. So,
Thank you.
yeah, just a reminder that SPIFFE is a specification, not an implementation. So it's not going to be part of the vote at the end of the episode. So it's more giving an idea of the problem space and how to solve it. So thank you so much for that, Frederick.
My pleasure.
All right, Daniel's up next. Welcome, friends. Daniel's going to teach us about SPIRE, and as soon as you start talking, your time will start.
Sure. So first, thanks for that great introduction to SPIFFE, Frederick. And SPIFFE and SPIRE are very closely related. Like I said, they kind of evolved together at the same company, came out of the same efforts. So there's a lot of overlap in these two conversations. But what SPIRE is it's a server for the SPIFFE protocol. So it sits here on your network and it sends out SVIDs. What is an SVID? An SVID is a SPIFFE verifiable identity document. So either an X509 certificate or a JOT. The SPIRE server creates these, it sends them to SPIRE agents. The agent's job is to verify the workload and give it the right SVIDs. And then obviously you need to do this twice. You need to have at least two workloads. Otherwise, it wouldn't be a very interesting conversation. You need to have two things that need to communicate. You give them both X509 certificates or both JOTs, and then they can establish a secure connection. One of the key things here is we do not actually establish this connection. We're not trying to do a zero trust overlay network or anything like that. We're just granting you the credentials that you need in order to establish that connection, which is way easier. We don't have to have network protocol implementations that are high performance in every single programming language or anything like that. We just give you the credentials you need to establish that connection. And then, like Frederick had shown in that previous slide, you typically don't just have one SPIRE server. You have a bunch of different domains within your organization, multiple different SPIRE servers. They can all talk either through federation, where they're trading their certificate root authorities, authority data back and forth, or they can be what's called nested, where there's a parent SPIRE server that generates the root information and then distributes it to child SPIRE servers. Either approach works fine, and there are valid use cases for both of those, and SPIRE supports both of those. And then the most important two questions are, first of all, how does the SPIRE server authenticate the SPIRE agent that's running on the node? Very important question here. Obviously, the entire basis of the security is that we have to know which node is talking to the SPIRE server. It's a pluggable interface where you can have different plugins that support different authentication methods. So if you're in the cloud, you can use AWS instance identities, you can use Azure instance identities, you can use Google instance identities. If you're using some other cloud, maybe Oracle Cloud, you could implement a different plugin for those instance identities. And the SPIRE agent will get that information and exchange it with the SPIRE server, and then be able to use that data to perform the authentication process. Now, if you're not in the cloud, that's where things get a little more interesting. You need something to prove the node's identity to the SPIRE server. So right now, the most common approach is to use a static predefined certificate that then SPIRE can build its authentication layer on top of. But there are other approaches, such as trusted platform modules. We support trusted platform modules in a couple of different forms for performing that authentication. Or we are working on support for AMD SEV confidential compute. That's in progress. That's a huge project. It'll probably take a little while. But like I said, these are pluggable authentication modules that fit into the SPIRE agent and perform that authentication process. And then the second big question is, how do you authenticate the workload? So again, it's a pluggable system. You can fit in any kind of workload authentication you'd like. The most common is to use Kubernetes. Just talk to Kubernetes and determine the identity of the workload, or talk to the OS. You can determine the hash of the binary that's running or hash of the Docker container that's running. But we also have some more interesting approaches, such as built on top of cosign image signing, which you were talking about last week on this channel. We can use notary image signing, a variety of different approaches for identifying the workload. So it's all up to you. You configure it. That can make it a little more complex at different times, because you can have this stack of different plugins that can do different things in different environments. So it can be definitely a little bit complex to use, but we provide lots of documentation and lots of guides. So what do you do once you have those identities? Well, like I said, you can establish a connection yourself from workload to workload. The other big use case is talking to cloud services. So you can take a JOT issued by the SPIRE server. You can federate the SPIRE server with AWS, with GCP, with Azure, and then you can use that JOT token to connect to other services. So if you want to authenticate to an RDS data store or some other Amazon service, you can just do that using SPIRE identities. You don't need a separate identity layer. So with that, I think I am out of time. But ask me any questions you want in the chat, and I'll try to get back to them before the end of the stream. So.
Wonderful. This was great. Thank you so much, Daniel. Appreciate you. We'll say goodbye to you shortly, and we'll see you soon. All right. Abhijit, welcome. Let me find your screen. And as soon as you start talking, Victor will start the time.
All right. Hello, everyone. So today I'll be talking about getting workload identity with Athenz. So Athenz is an open source project which was developed at Yahoo, and then it became a CNCF sandbox project in 2021. So at its core, Athenz provides these two main features. One is the service authentication in the form of X5 certificates, and second is the authorization via role-based access control. And we'll be looking at the authentication much more detail today. So here are some more details that Athenz issues short-lived certificates. Each instance or each service gets its own identity. So if your instance is deployed on 50 pods or 50 hosts, every instance gets its own unique certificate. Athenz also supports automatic certificate bootstrap and refresh. And how it does is we'll see next. So how Athenz achieves that? So Athenz has a concept of providers, which makes it very fully flexible and manageable to work in any environment. So today Athenz supports Kubernetes, AWS, GCP, and few more. So Athenz has two primary ways of doing that. One is the class-based provider, for which the implementation lives in the Athenz code base, something like an in-tree implementation. Or there can be an HTTP-based callback, which is out of tree, which Athenz can make a call over HTTP to validate the attestation data for a given workload. So before we look at how the identity is bootstrapped using Athenz, let's quickly take a look at Athenz's data model. So Athenz is meant to be a multi-tenant solution from day one, which means that you can have one single deployment of Athenz for the entire company, but still your products or departments or verticals, they can still have full control over how identities are issued for their own components. So Athenz does that by the concept of, we call it as domains. So each domain is a standalone entity which is independent of each other. And you can think of domains as something like namespaces in Kubernetes. And then your applications or your components became services in that domain. And then the domain has a concept of domain administrators, who are the human users who have full control over that domain, thereby its services and how the identities are issued for those services. Now let's see how the identity bootstrap process works. So Athenz provides a service identity agent, or SIA, to work in various environments. So the service identity agent is primarily responsible for three tasks. One is to create a private key and generate a CSR. Two is to get the attestation data about that workload. And three is to request the identity for that workload from the Athenz backend. So whenever an instance is launched, each and every provider usually has a notion of identity. So the SIA, or the service identity agent, takes that identities notion or that attestation data and makes a call to the Athenz backend. Once that call is received on Athenz backend, it does series of checks. The first and foremost being whether the domain administrator have explicitly authorized their service to be launched in this provider or not. Once that check is successful, then the most crucial check among all of the other checks is whether that attestation data is valid. So let's say in case of Kubernetes, if we are using a service identity token with the audience for Athenz, then Athenz will talk to the cluster's OIDC provider and make sure that the token is signed by the OIDC provider, it's not expired, etc., etc. Once all those checks are successful, ZTS will talk to its signer backend and then issue the identity to the workload. So this is how the bootstrap process works. Similarly, once that identity is bootstrapped, there is a regular refresh. So refresh does pretty much all of those same checks. In addition to that, the the refresh itself is a mutual TLS call to the Athenz backend using the identity which was provided during the bootstrap. So now that you have the identity, then you make a mutual TLS call to Athenz backend using that identity to refresh yourself. And among all the other checks which I just mentioned, Athenz backend also makes sure that not two instances are using the same certificate to refresh their identity, right? And then everything else remains the same, and Athenz issues a refresh certificate back to the workload. And talking about SPIFFE, Athenz identities are compatible with SPIFFE, which means that the Athenz provided X509 certificates contain SPIFFE in their SAN URI. So any product which is integrated with SPIFFE or which understands SPIFFE, like Envoy or Istio, they can work with Athenz as well. And that concludes my presentation.
Wonderful. Wow, no gong today. Victor, how do you feel?
No gong, I'm disappointed.
No gong.
Shall we do another round to see whether they'll fail? No?
I can keep talking and give you a chance to.
Too late.
Daniel, you're back on the screen if you want to share yourself. Hello. Welcome. Hello, everyone. So, Victor, you have a crystal clear understanding now, right? Yeah.
Yes, I know. I'm speechless.
We have a lot of questions, and we're going to do these in first come, first serve. So if you have more questions, please do ask them sooner rather than later. I have a question, and I get priority access. What persona implements SPIRE or Athenz at a company? So let's start with you, Abhijit, about what persona would be interested in Athenz.
So Athenz can be implemented as a deployment for the whole company. So that can be something like a platform team, which is just deploying and maintaining Athenz for you.
Cool. And what's your experience with that, Daniel? What persona wants to implement SPIRE?
My most common experience is with a security engineering team within an organization. They look at all these microservices that programmers have deployed, and they're like, "Oh no, we needed some way to make sense of this." So they deploy something like SPIRE or Athenz centrally, and you want to build it into the platform. You want it to be alongside your other core platform components, because ideally every single service in your infrastructure would use this technology.
Cool. Yeah, that's what Victor and I were talking about a couple of days ago, is that it seems like these technologies are meant to be, they're kind of complex to maybe configure and set up in the first place, but then they're meant to be used system-wide as opposed to setting up different versions for every different microservice you have. Is that correct?
I think that's true, unfortunately. It would be great if I could say this is super easy to deploy. But unfortunately, in my experience, it is a big project. We are really trying to make it easier. We have standardized Helm charts that are coming out for SPIRE. So ideally, you'll just be able to deploy those Helm charts and get a decent subset of the functionality for free. But unfortunately, you do need to have a pretty deep level of understanding right now to use these technologies.
Right on. Is that true to Abhijit of Athenz, that you need a pretty deep level of knowledge to implement?
Right. I mean, it's basically, as Daniel mentioned, similar to SPIFFE or the SPIRE plugins. Athenz does have way to extensible mechanism to implement, and then yes, it does require some controls and knobs to configure. But yeah, once you have it, you should be able to use it with all of your services in your company.
Cool. And Frederick, I'm going to give the first audience question to you, because it says, how does SPIFFE integrate with Azure? Does it act like a managed identity?
Oh, that's a great question. I was hoping this would go to someone else because I'm not too familiar with all the offerings of Azure, and I am going to take a look later on.
The story must be similar to AWS, Google, right?
Yeah. Let's talk about clouds in general, though. So there was a announcement or a talk with at Google I/O last year where they said that they were going to start incorporating SPIFFE IDs into some of their identity solutions. And my hope is over time, as the specification continues to catch on, and it's already caught on in a lot of areas. So there's some very big private deployments out there that exist. I don't know which ones I can say publicly or not, so I'll refrain at the moment. But if you're using Istio, you already have a SPIFFE ID in there that you're already using. So my hope is over time it becomes more turnkey for many of the clouds. But you still need a whole bunch of things for on-premise, or what if you're doing IoT or similar, where it can really help. So I expect things like SPIRE and so on to continue working. A common integration that we see, though, is we often see the SPIFFE identity, the SVID that is signed, or I should say, be more specific, the X509 or JWT, are often signed by a KMS, and that KMS is managed by some cloud infrastructure that is tightly, or that is very carefully defended by some platform team or by some information security team that owns that identity provider. So that then gives them the provenance to say this key was issued by us through the secure path, as opposed to having signing keys just exist in random places. So the level of integration really depends. Like we're hoping over time that we get better integration where it becomes more turnkey, but you can still tie into things like KMS or other similar technologies within cloud.
Cool.
All I can say on my end is that the Microsoft Entra team, their managed authentication team, they are very aware of SPIFFE. They attend a lot of the meetings. They ask a lot of questions. I don't fully know exactly what they're working on. They won't tell me, but I can definitely hook Jens up with some of the people working on that project within Azure. So
Awesome. And they can reach out to you where? In the
yeah, any place, CNCF Slack, SPIFFE Slack, Twitter, whatever works.
Awesome. Cool. All right, Abhijit, is Athenz useful with public cloud Kubernetes?
Yes. So Athenz today, like we do have, like within Yahoo itself, we have both AWS deployments as well as GCP deployments. So Athenz works perfectly fine with EKS or GKE, or for that matter, it can work with a normal vanilla Kubernetes as well.
Wonderful. And same question for you, Daniel. Is SPIRE good with public cloud Kubernetes?
Yes, and ideally, some of those cloud services will start to integrate SPIFFE and SPIRE, but they're not quite there yet. But they'll get there. But yes, we have deployed it on Amazon Kubernetes, on different managed Kubernetes providers. OpenStack Kubernetes gets a little bit interesting, but that's not a managed service. So.
Right on. And then Frederick, this one's for you. Nick is new to this topic. What problems do these technologies solve that OIDC wouldn't?
Fantastic. So when you think about OIDC, usually what happens is you follow it. It's an identity provider built on top of OAuth. OAuth is authorization. And usually it's about the user. How does the user connect in? How do you correlate an identity to a user within some identity provider like Active Directory or Okta or similar? So the idea behind this is, first, these systems are designed for service to service, workload to workload. Not to say you cannot use OIDC for those, because you totally can. There are also integrations with like, I know for sure for SPIRE, and I'd be surprised if Athenz did not do this as well, where you can correlate an identity over OIDC to your SPIFFE identity, and then when you connect in, you have a projected identity from whatever your single sign-on system is, but simultaneously tied to your workload identity as to what your system is that you're using. So there's ways of integrating these things together. The primary purpose of these particular systems, though, is how do you issue out those X509 certificates? How do you rotate them? How do you control them and give you the ability to use things like mutual TLS in the easiest way possible?
I have a question. In my mind, OIDC was more about authenticating humans in a system, and SPIFFE SPIRE Athenz is about authenticating processes. Is that accurate?
For the most part, you can use OIDC for the other, and you can use SPIFFE to identify humans, but it's not as common. But those are the general lines where most people end up drawing it. But when you want to connect in, let's say you want to do like you're working with AWS and you want to make a call to, let's say, S3, and you end up using that OIDC in order to federate your identity, then there's some interesting workloads around. There's some interesting paths around that you can use to assist with that, where you have a workload and you're using it to identify what that other thing is, and you're using the underlying protocols. Within OIDC, there's an endpoint called well-known. So when you get that token, you can use that well-known API to say, I have this identity, tell me more about it. And it gives you back that information. So there's some interesting things there that you can use to tie in with systems that provide OIDC. But simultaneously, you don't need to use OIDC with SPIFFE, but it is there when you need it.
Cool. Abhijit, what benefits in a Kubernetes-based environment to Athenz provide over the built-in identity solution meshes like Istio, for example?
So in this case, what we are talking about is like, for example, this is based on my limited understanding how Istio works. As Istio control plane would still have to give you some kind of an identity, right? It will use, I think it used to call that component as Citadel. So Istio control plane would still have to give you some kind of an identity, which then will be used to represent your workload. So Athenz or Spire will do the same for you. So instead of using some identity, which is, let's say, only for a given cluster, you can use a company-wide identity, and that can represent your service within the cluster or outside the cluster.
That's very helpful. Do you have anything you want to add to that, Daniel?
Yeah, it's a really complicated question, actually. But Istio does have a built-in identity layer, and it uses SPIFFE identities. So it actually does generate SPIFFE compatible identities. So if you're using Istio, you are using SPIFFE in a sense. I could go on and on and on about that.
but let's just pretend Istio is not, or take just another technology entirely.
Oh yeah. So Kubernetes provides projected service account tokens, and the issue is we call them PSATs. I don't know if anyone else calls them that, but I call them PSATs. It's called a projected service account token. It's only valid within one Kubernetes instance, though, within one cluster. So if you have multiple clusters, that doesn't really help you for communicating between clusters.
Yeah. So you second what Ajit said.
Mm-hmm.
Cool. And then
when we have a service mesh that is set up to do multi-cluster networking, then service meshes, I guess, would have to provide some global identities, I'm guessing, right? For all that to work.
Yeah, one thing with that as well is that within SPIFFE, there is a way to federate trust domains together. So you don't necessarily want to have two clusters where they're not always owned by the same group, or maybe they may even be owned by the same company, but they may have separation between them for security reasons. And this provides a path where you don't have to join them together at such a low level, and you can still reason to them at a cryptographic identity point.
Oh, love that. Okay, so this one will be for you again, Abhijit. What if my Kubernetes pod needs to have two different managed identities? Is there a use case for that? For example, my app needs two SQL database users, one for elevated access, one for regular.
This to me sounds like a different subject, or am I wrong? Sorry,
right.
Go ahead.
So no, I think you're right. So here we are talking about the identity of that workload itself. So we're not talking about what users or how that identity is being used in other systems like MySQL or your SQL database, right? So here the identity is still one in my mind, which represents what your service is. Then how that service is using SQL database, then it can have 1, 2, 3, n number of users to do however operations you want to carry out. And those users will have different authorization levels inside the database. But as far as your service goes, there is still one identity which says that this is service X.
Well, before we move on from this as well, it is possible. Like if you look at Postgres, you can configure Postgres with mutual TLS, and it'll actually lift the identity straight from the client certificate. So if you have two workloads, I have one workload that's designed to work with, let's say, with payments, and the second one was working with some sensitive information, like maybe healthcare information or banking information. Then that microservice may have a different set of credentials that you wanted to use. So you can use when those microservices actually connect, you could correlate the identity to those specific users and only give them access to those tables and to those functions or rows in the way that you want to. So it can help drive that identity so you're no longer sending a bearer token to connect in or username and password combo. Instead, you're saying use my infrastructure's dial tone identity to connect and identify what this thing is.
Cool. When we say ID tokens, do we mean OIDC, OpenID Connect?
When we say jot tokens, we mean OIDC tokens. An OIDC token is a type of jot token, and they should be compatible. OIDC specifies the way the root of trust for jot tokens is transferred, but it actually does. It just uses jot tokens.
Cool. And then another one for you, Daniel. How does SPIRE store identity metadata? Is it centralized data store, or is each node agent stores its own copy?
Oh, this is a fantastic question, because it's a very active topic of discussion. But yes, it's a centralized data store. It uses an SQL database. For a small installation, it's a really small SQL database, but we do have some users with like hundreds of gigabytes of SPIRE metadata. And it actually becomes kind of a chore to maintain that SPIRE metadata. These are like very large organizations, so with millions of users. So it is a centralized SQL data store though right now.
Cool. And Abhijit, is it possible to integrate Keycloak with Athenz? Do you know?
I haven't tried that, but I believe it should be possible. So Keycloak is supposed to represent what, human identities? Is that what the question is going towards?
Mm-hmm.
Yes.
Right. So, like for example, in Athenz, we have a concept called as user authorities, and Athenz doesn't really deal with human authentication. What Athenz does is it sorts of let the underlying user authority take care of that. Like, so it can be Auth0 or Okta. So similarly, I believe Keycloak can work as well.
Cool. And what about for SPIRE, please, Daniel?
Yeah, so Keycloak is a human identity provider, stores usernames and passwords, and then can perform OIDC authentication. So it isn't normally used with SPIRE. There is a user, I'm thinking about, there's at least one blog post or conference talk, I don't remember, from IBM where they are actually using Keycloak and SPIRE together. And they're basically, I believe, using SPIRE to authenticate to the Keycloak server. I can track that down in more detail. It was a long time ago, but there are a number of people at IBM because they use Keycloak for their cloud services.
There's a blog post about it too somewhere. Probably on Medium is my guess.
All right.
Cool. All right. And this one for Frederick. If I'm developing a microservice as a developer, do I need to code program my microservice for a specific solution? Or like, so is there a specification like for OpenTelemetry, or do I need to know what solution I'm using when I'm configuring my microservice?
Okay, so this one is an architectural question. It's possible to do it in either way. So, for example, a project I worked on significantly in the past, network service mesh, we integrated directly with SPIFFE. We brought in primitives directly into it, reasoned about the identity directly. Simultaneously, you could also, if you have a web application, let's say a microservice that's just emitting out HTTP request responses, you could wrap this around something that spoke SPIFFE. This is exactly what Istio does. The workloads that sit underneath of them have no concept of what SPIFFE is, but they still get the protection of mutual TLS with the SPIFFE identities for the authentication component. So it really depends. You could go either way. It really depends on what your needs are. And there are some capabilities you get when you integrate with the workload, but of course you now have to maintain it and it increases the complexity.
Excellent. Abhijit, does Athenz work with Linkerd?
I haven't tried
that one.
Yeah.
Okay.
No, sorry. I thought it was a SPIRE. No, nothing.
That'll be the next question. Yeah. Does Athenz work with Linkerd? Do you know?
We haven't tried that, but I'm sure it can.
Cool. And Victor, does SPIRE work with Linkerd?
Since the end of last year, yes.
Yeah.
I think it was 2.15 release or something like that, November, December 2023, that SPIRE was added.
Oh, I'll have to take a look at that. I didn't actually know that. We've done a lot of work on Istio. So, yeah.
Victor has one win this episode. Good job.
No, lots of wins.
Awesome. And this is the last question we have so far. So We'll start with you, Daniel. Does SPIRE work on Windows-based workloads in Kubernetes?
Yes, it does. We have a very large user in a Windows Server environment, and there were some code changes required for that because of the way workload authentication works at the workload layer. The way that socket has to be established is completely different from on Unix platforms, but yeah, it does work. It's supported. So.
Awesome. And what about with Athenz? Does Athenz work on Windows-based workloads in Kubernetes?
We haven't come across any use case for that, so we haven't tried that. But the service identity agent with Athenz provides, it does work on Windows platform. So I'm assuming that it will not be a very big task to get it working on Windows-based Kubernetes. Yeah.
Amazing. And that's the last of our questions. So we're going to have each of you make a closing statement, one last plea for a vote. So Frederick, even though no one can vote for you, like give us a summary of SPIFFE in just a couple sentences, please.
So SPIFFE, so first, thank you all for coming in and listening to all of us.
Is he gone?
Yeah.
I think
Wait,
he might be gone.
I'm back.
That was
I think.
amazing closing statement.
All right. We're all at the edge of our seats.
Am I back online? Or
Yes, you're
Yes.
back online. Yes.
Okay, yeah, you all disappeared to me. Yeah, so first, again, thank you. In terms of SPIFFE, please do think of it as a specification that you can implement. You don't have to use these technologies if they don't fit your needs. My hope is that they do fit your needs and you can just use it and not have to pay the cost of implementing another thing that's out there. And I think in terms of in terms of SPIFFE, if we end up moving in the same direction and all end up using SPIFFE together, then over time that'll simplify a whole bunch of federation and peering problems down the line, because those are really hard problems to solve. And right now, all we have are primarily bespoke solutions for connecting things together, and which makes it very dangerous. So again, thank you, and I'll yield the rest of the time.
Thank you so much. All right, Daniel, what's your closing statement? Why should we vote for SPIRE?
Sure. I think the quick summary is that SPIRE is designed to support SPIFFE in a wide variety of different environments, different workload authentication, different node authentication. Like I said, Windows, different clouds, different managed Kubernetes providers. And if it doesn't support something, it should be possible to make it support it by adding new plugins, adding new configuration. Now that does make it a little more complex than Athenz, I think. It's a little bit of a bigger lift, but hopefully we've made it easy enough with good documentation and good sample configuration, Helm charts, like I said, that it's easy enough to set up for different environments. And like I said, it's not really a competition. Both projects are open source. They should be compatible with each other. They both implement the same APIs, so they should work together nicely.
Exactly. Yes, we're all friends and community for sure. Thank you so much for sharing your time. And
thank you, Whitney.
Thanks, you. Bye.
Thanks, bye.
Thank you.
All right. Why should we vote for Athenz, please, Abhijit?
All right, so we just talked about how workload identity can be generated using Athenz, but in addition to that, like Athenz can provide workload identity, it also provides a complete RBAC solution for role-based access control. So you don't have to be limited to just authentication, you can do authorization as well. And you can use Athenz as a complete security solution to both authenticate as well as authorize your microservices. And Athenz can be integrated with other projects. Like we are gonna release a new plugin for Athenz to work with Cert Manager. So wherein you can deploy Cert Manager and then you can get Athenz identity via Cert Manager. So that can be a complete solution for your security needs, especially for your services and your workloads.
Amazing. Thank you so much. Thanks for sharing your time today. Goodbye.
Thank you.
Awesome. Votes at our #YouChoose channel. And also, if you have a question that we didn't get to today, if you're watching the recording and you have a question, please post your question to the YouChoose channel too, and we'll make sure the relevant expert sees it and answers your question.
The link is in the description. Don't try to memorize this nonsense.
3 and V7.
Or don't try to click on a video. That doesn't work either.
Next week, we're going to talk about Keycloak and Dex. So this is a similar establishing identity, but more about establishing identity for human users as opposed to workloads. So we'll be talking about OIDC next week, which came up this week too.
That's easy. No humans should be allowed to your cluster. Period.
Only robots. My website is only meant to be consumed by web crawlers. No actual human should visit it. Perfect. Easy. Never mind. Don't come next week. In fact, I'll cancel it. I'll call our Keycloak and Dex experts now. All right. I think that's a wrap. Thank you so much, everyone. You're wonderful. Thanks for sharing your time. And we'll see you next week. Bye.
Bye-bye.